Hello everyone. So the topic for today is gradient, divergence and curl. These are the mathematical operations which are used in many physical problems related to electrodynamics. These are the fundamental operations in vector calculus. So to dive in the topic, first we have to understand what is del. Del operator. Del operator, which is shown by this symbol, inverted triangle, is also known as nebula operator or nebula, simply nebula. This is a vector differential operator. This is not a vector quantity, it is a vector differential operator. And we define del by I cap del by del x plus j cap del by del y plus k cap del by del z. Here, I cap, j cap, k cap are the unit vectors. So, if we operate del function on any scalar quantity or scalar function, suppose we have a scalar function phi here and we operate del on any scalar function, we will get the gradient. Or it simply says gradient of phi. And if we operate del on any vector function a cap, a vector via dot product, we will get del dot a, and this is known as divergence of a. And if we operate del operator on any vector function via cross product, we will get curl of vector a. So now understand gradient, diversion and curl in detail. So first we have gradient. So whenever we operate del function on any scalar function, it is known as gradient of that function, means gradient of phi. So what gradient actually show? So gradient means it show the direction of maximum change. The physical meaning of gradient is it shows the direction of maximum change. Gradient is basically a directional derivative. For example, temperature gradient. As it is a vector quantity, the result will be vector quantity. So there will be magnitude as well as the direction. So if we have a iron rod having 2 points A and B, the starting point A having the temperature 70 degrees Celsius and the ending point B is of 30 degrees Celsius, and we know the heat flow from higher temperature to lower temperature. So the direction will be from A to B till the whole road will get the uniform temperature, means 50 degree here and 50 degree here. So the magnitude as well as the direction change here in the temperature gradient. Another is potential gradient. The potential change means the minus of the negative of dV by dx. Dx means the length. If I'm saying here dt by dx, x is here the length. The length of road is x and T is the change in temperature. So the gradient is dt by dx. So the del operator means the value of del operator is I dot del by del x plus j dot del by del y plus k dot del by del z and T. T temperature may be anything. Next is divergent. Divergence means if we operate del function on any vector product via dot product. Sorry, if we operate del function on any vector function via dot product. So we will get the divergence. Divergence of A. So A is here any vector function via dot product. We operate del on A and we get the divergence of A. Suppose we have del operator A vector could be anything. So if del I dot del by del x, j cap del by del y, k cap del by del z, or suppose the vector A is 2x plus 3y plus 2xi 3yj and 4z k cap. 2xi cap plus 3yj cap and 4z k cap. And we know I dot I is 1, j dot j is 1, k cap dot k cap is 1, and I dot j dot j dot k dot k dot I dot is 0. So we will operate it I dot I, j dot j and k dot k. So we'll get the answer del by del x 2x, del by del y 3y, del by del z 4z. So the answer will be 2, 3 and 4. 2 plus 3 plus 4, 9. So the value of divergence A is 9. The physical significance of divergence is, so here we get the scalar quantity. So first the result is scalar quantity. The result is here scalar quantity, and the physical meaning of divergence is how much a vector field diverges. Suppose means the physical meaning of divergence is flux. How much a vector field diverges. The outward flow per unit volume. Suppose we have a point and field is diverging. So this is positive diversion and this is known as source. Here field is spread outwards. And if we have a point where the field is coming inside, this is negative diversion. and called it as sink. Here, field is converging inward. And if we have a diversion like this, where field is coming and going, means outward flow and inward flow are same. So we will call it as zero divergence. Suppose we have if diversion is zero, means this situation where the incoming diversion is equal to outgoing diversion, the diversion A is zero. So here the vector A is known as solenoidal vector. Next is curl. If we operate del on any vector A via cross product, then this is known as curl of vector A. So if we find the curl, suppose we have the example A is equals to 2xi plus 3yj plus 4zk, and we have to find out the cross product. So we will find it out by the determinant method. Cross product I cap, j cap, k cap, del by del x, del by del y, del by del z, 2x, 3y, 4z. I cap, del by del y, 4z minus del by del z, 3y minus j cap, del by del x, 4z minus del by del z, 2x plus k cap, del by del x, 3y minus del by del y, 2x. So we will get the result 0. As the name suggests, curl, the physical significance of curl is it will show how much a vector quantity curl. In the situation where curl of any vector is 0, A is known as the vector A is known as irrotational vector or conservative field or primitive vector. And as it is a vector quantity, the direction will be perpendicular to plane of area. So the physical significance is the rotational property of vector A. So the del operator nabla is a vector differential operator and it is defined as I cap del by del x, j cap del by del y, k cap del by del z. And if we operate del function on any scalar function, we will get the gradient phi. And if we operate the del function on any vector via dot product, we will get the divergence A. And if we operate the del function on the vector function via cross product, we get the curl A. So on gradient, whenever we operate the del function on any vector product, we will get the vector quantity, and the significance is it will show the direction of maximum change. Have the example temperature gradient and potential gradient. And in case of diversion, if we operate the del function on any vector function via dot product, we get the diversion of A. And the significance of the diversion is how much a vector field diverges. Suppose if it diverges, we will get the positive diverge and it is known as source. Here the field is spread outward, and if the field is converging inside inward, it is known as sink. And if the inward field is equal to outgoing field, it is known as zero diversion. So the physical significance of diversion is flux, and it gives the scalar quantity, means how much field is coming and how much field is going outside. And if the diversion of A is 0, means there is no field coming and no field going outside, the diversion of A is 0, and here the vector A is known as solenoidal vector. And if we operate the del function on any vector product via cross product, we will get the curl of A. So suppose we have the example 2xi plus 3j cap 4zk cap. We will find it by the determinant method. And the physical significance of curl is it will show the rotational property of any vector A. So the curl means how much a vector quantity curl or twist. So if we have the del operator cross product with vector A, and we will get the answer 0, that means the vector A is irrotational vector, or it is a conservative field or a primitive vector, and the direction will be perpendicular to the plane of area. So that's it for today. I hope you like the session. Please like, comment or share, and on next video we will do some question exam related, exam oriented question. Thank you.